Hey Algebra 1, wanted to do a homework video to kind of teach us a little bit about what we learned today. Today we talked about how to graph linear inequalities, and we're only starting with 1 today, and later we'll do a system, which is 2, and so we really want to develop a vision for how to do 1 at a time. So other than graphing the line, there's a few things that are different. You could be creating a dashed or maybe even a solid line. And so what makes that a solid line is really if you have permission for it to be equal. So the symbols that I just circled down here, those are less than or equal, greater than or equal. But in general, when it's or equal, you have permission for the points on the line to be solutions. And so for this first one, I want to graph using mx plus b. My y-intercept value is -4. And now for my slope value, 5/3, positive 5/3, so up 5, right 3. Do that again, 1, 2, 3, 4, 5, 1, 2, 3, sorry. And so now I have to think, well, should I draw a solid line through these points or a dashed line? And so because I have that or equal symbol here, that little line that gives me permission for the values to be equal on both sides, I want to use a solid line for that graph. So the second part is, where do you shade? Do you shade above the line or do you shade below the line? Well, it really depends on the inequality in the problem. And so this one here is the less than or equal symbol. And so the or equal part we have, it's solid, meaning any point on that line is a solution, but less than, we need to go lower than the line. So for example, our y-intercept value is at -5. Should I go up to values like +6, or should I go down to values like -6? Well, less than, you should be going -6, or any value lower than that first line. And so here we go. We are shading all the points that are below that first line. Okay, because we're really trying to show all of the ordered pairs that are a solution to this inequality. So let's try another one. This one starts at 7. 1, 2, 3, 4, 5, 6, 7. And its slope is -1/2. So it's going down 1, right 2. Down 1, right 2. I can even go up and left 2, but that would still create a -1. So should this be dashed or solid? Well, this one has to strictly be greater than the line. So it can't be or equal. So that is why we want a dashed line, which means points on the line are not in the solution, only points greater than that line. So when we shade, we'll ask ourselves, well, what is that symbol? That symbol is the greater than symbol. And so we want to shade greater than this line. So we started at that point 7. 7 was the y-intercept. Well, values above it, like 8, well, that would be greater than 7. And so we want to pick any point that is above this line. Your solution space is any point above the line. All right, so let's talk about some that are not in that graphable form, when that y is not by itself. You have to move the equation around a little bit to get y by itself. So for example, in number 3, I want to start by subtracting 2x to the other side. Y is less than -2x plus 1. And this one only has one step because I don't have 2y or -3y. It's just positive y. So when you move 2x to the other side, we now have slope-intercept form. So I want to start at +1. 1 is that y-intercept that we see in the equation. And now we want to use the slope value, -2, to find another good point. Down 2, right 1. Down 2, right 1. And do that as many times as you can for as many points on the line as you can. So in the past, we would just connect this together, but now we have to ask ourselves, should this be dashed or should it be solid? Should we draw a solid line through those points or should we do a dashed line? Well, we have to ask ourselves, is there permission to be equal to the line itself? And the answer to that is no. We have to be strictly less than. So we do not want that solid line because we do not have a solid line for or equal. That red line I just drew is not there, and that's what determines it. So I want to draw a dashed line going through these points. And now I have to ask myself, should I shade above that line in region 1 or should I shade below that line in region 2? Well, it depends on the inequality. And in this one, this symbol is less than. So you should be shading lower than the line. So, I mean, just think about the y-axis. This would be above the line. This would be below the line. And so less than, you better be shading in region 2. All of these points are solutions to the problem. So I don't do this for everyone, but I will show, for example, here's the point -2, 0, which means if you plug in 2x, 2 times -2, plus y, y is 0, that comes out to be -4, and that is less than 1. That is a true statement. So that point, -2, 0, that's in that green space, that I did shade correctly because that point should be on the line or should be in that inequality. But for example, this point way over here, 1, 2, 3, 4, 5, 6, 7, 8, 0. This point is not in the solution space. 2 times 8 plus y, or 0 in that case. See, this is giving you 16. Is that less than 1? No. And that's why this point is not in the solution when we shaded it. So we can always take a moment to test to see if we did it correctly. Are the points that we say are in the solution, do they work when you substitute them into the problem? So let's try one that's a little harder. That one only had to subtract 2x and you were kind of done. Let's do one that takes more than just 2 steps, or more than just 1 step. So I want to subtract 2x to the other side, -5y. Some students just put 5y there. That's a place where you can miss it because you lost that negative there. -5y is greater than or equal to -2x plus 30. So now I want to divide by -5. And something that was in a lesson several moons ago, we talked about solving inequalities. And anytime you divide a negative across that inequality, this sign for the inequality has to change directions. So it was a greater than, but because we divided that negative to the other side, that is what ultimately has changed that to be the opposite. It's now less than. So I'm going to keep cleaning up. Negative over negative, positive 2/5 x. 30 over -5, -6. So now we've taken a moment to solve for y. And we're going to start at our y-intercept of -6. And then we're going to use that slope to go up 2, right 5. Or maybe go backwards, down 2, but left 5. So now we have to ask ourselves, should this be a solid line or a dashed line? And for this one, because it's or equal, it has that line under the inequality that's solid. That means we will make a solid line through these points. So now we have to ask ourselves, should I shade above that line, region 1, or below that line, region 2? Well, it depends. Is this a less than or greater than symbol? For this one, that is a less than. So number 2 would be below the line. Shade below the line. All the points below that line are in the solution. Okay. Gonna do two more that are similar to that. Gonna speed up a little bit for the time that I have in the video. Let's subtract x from one side to the other. Negative y, sorry, that is really hard to read. Negative y is greater than negative x plus 5. Well, we now have this negative 1 that's out in front of that y that we need to move over. So I'm going to divide everything by negative 1. But hopefully that's something that you know will change the inequality direction because you divided by a negative across that inequality. That makes this positive x minus 5. So I'm now going to start at negative 5 right here. And then we're going to use that slope of positive 1x. I'm going to go up and over, sorry, up and right. Up 1, right 1, up 1, right 1, or down 1, left 1. So now I have some points, like for example, this is the point 7, 2, and if you plug in 7, 7 minus 5 is 2, so that's a way that you can double check that this is correct. Should it be a solid line or a dashed line? So I'm going to go back to my notes. I know I've been talking about it in this, but these are the notes that we took in class today. And so it says right here, to graph the line, you are either using, I'm so sorry, you are either using a solid line, and that is if it is less than or equal, greater than or equal, but in general you are looking for that line that is under each of those. But it should be dotted, sometimes I call it dashed, a dashed line, if it's just less than or just greater than. You don't have that symbol with a line under it. So, thank you for being patient. Going back, this needs to have a dashed line because it is just less than. Well, less than is below the line. So hopefully you are shading or slightly coloring below that line to suggest any point down here is correct. For example, let's say you have the point 10, negative 10. 10, negative 10 is in the solution. If you do 10 minus negative 10, will that be greater than 5? Yes. That ends up being 20. 20 is greater than 5. So that point is in the solution. However, let's try the point 0, 0. 0, 0 is the origin. The origin is not in that shaded region. If you do 0 minus 0, would that be greater than 5? No. 0 is not greater than 5, and that's why it's not in the solution. So I'm going to do one more. Hopefully you'll do the back for homework. We'll check your answers tomorrow in class. Let's subtract 2x from one side to the other. Negative 6y less than or equal negative 2x minus 24. Divide negative 6 to the other side. Y is greater than or equal to 1/3 x plus 4. So be very careful with your signs. Make sure you're conscious about negative over negative. Remember that if you divide by negative, that sign will change. It doesn't always change. So now I want to graph my line starting at 4, up 1, right 3, as many times as you can. And then ask yourself, should this be a dashed or solid line? This is a solid line that should be going through these because it is or equal. Equal signs use a solid line, so or equal will also use that. And now we have to ask ourselves, based on this word, is that going to shade above the line or below the line? And this inequality is greater than or equal. Okay? So when it's greater than, hopefully you think greater is up, and so we want to shade above the line. And so any point up here in that region is in the solution. So if you take a moment to try 0, 0, 2 times 0 minus 6 times 0, well, all that is 0. Is 0 less than or equal to negative 24? No, and that's why it's not in the solution. Good luck, and we'll check your work tomorrow.